I'm Rahul, and today I'm gonna present about MQTT. That's Message Queuing Telemetry Transport. So, for the background, we should know first what is IoT and what's MQTT. So, for IoT, the IoT is a Internet of Thing that describes physical objects embedded with sensors and actuators communicate with computing system via wired or maybe we can say wireless networks. IoT use variety of technologies connect to the digital and physical worlds. Physical objects are embedded with sensor which can monitor things like temperature or motion or really any change in environment. So massive IoT interconnects an enormous number of devices and service over internet for a broad range of application. So the message queuing telemetry transport defined as a low bandwidth consumption and a machine-to-machine protocol that helps the device to communicate with each other. So for let's talk about the history of MQTT. So the MQTT was generally created by Dr. Andy Stanford of IBM and Erlen Nipper of Acrom in 1999. And the main use case was to create a protocol for minimal battery loss and minimum bandwidth to connecting all pipelines over satellite connection. So their general purpose was it should be a simple to implement provide a low quality service data delivery and lightweight and should be bandwidth efficient. So let's talk about some OSI models. So in OSI model, MQTT protocol, we can see it stands in a application layer. So MQTT considered an application layer protocol because it operates at a top layer of the OSI model and the application layer responsible for providing a high level interface protocol for communication between applications such as email, file transfer, and remote login. So now let's look at the architecture. So this is the architecture where we can see MQTT broker and we can see also a server and topic. So so we can say here there are four main parts. Let's talk about the MQTT client. So the publisher subscriber model is different from traditional client server model. MQTT follows this publisher subscriber model. So it separates the publisher that sends a message from subscriber that receives the message. The publisher and the subscriber do not need to establish direct contact. We can either let multiple publisher publish the message to the one subscriber or let multiple subscriber receive message from one publisher at the same time. So let's move to the broker, or we can say it's server. A broker is a server that acts as a intermediary between publisher and subscriber. The broker is responsible for receiving a message published by publisher and delivering the message to the subscriber they have subscribed to. And let's move to topic. The topic is a label associated with message and it usually part of overall application message. Each subscriber client must subscribe a topic to and the broker sends the message from the publisher. So let's the message is the main part of the MQTT. So the message is nothing but a unit of data that is exchanged between a publisher and a subscriber. So there are generally three parts. The one is payload, another is quality of service, and another last one is the topic. The payload is actually a data that being transmitted. It can be any binary data such as sensor reading, telemetry data, or we can say a simple text message. Topic is a string that represent a category of channel which the message is published or subscribed. And there is one other thing that is quality of service. So there are three part: level 0, level 1, level 2. So level 0 means at most one, like the message going to deliver at most one, at least one the at least one time. Level 1 there is at least one, but like the message will be delivered at least one time. And the level 2 means exactly once, like message is going to deliver exactly one. So now let's take example of how MQTT works. So this is the what we can say a smart agriculture. In this subscriber publisher model, the one which sends the data command is termed as a publisher, and the one received data or command is termed as a subscriber. The moisture sensor publish moisture data and send it to the broker, which when received by the subscriber can generate an alert based on threshold value. If the moisture level is low and the user wants to turn on the sprinkler, then the user device publishes the data command to turn on the sprinkler on, and the sprinklers receives the command and act the water well. So now there is a comparison between MQTT and HTTP. So you can see the graph. There is lots of difference between MQTT and HTTP. So it has a low power consumption, then low bandwidth usage, and effective message transmission. But we can say we can use as we require, like it's on your purpose. That same goes for web sockets. So there are no main difference between web socket and MQTT. Web sockets are intended for real-time and bi-directional communication. So we can say as we need to use. So there is one also thing that if we don't have any sensor or physical object, then we can check how MQTT works with MQTT box. So here we can see we can give a name to your MQTT client by filling the MQTT client name field and choose the MQTT TCP form the protocol drop down list and enter the public address of your thing stack instance in the host field. If you want to enable TLS security and choose MQTT TLS as a protocol and use public TLS address, then enter the host detail and client ID. Then just enter the save button. After this, you will be able to see the publisher subscriber screen. Here you will enter the topic name and publish and set quality of service and payload type. Publishing a message doesn't make sense if you are not if no one receives it. So if there are no clients to subscribe to the topic name, so we need to subscribe to the particular topic to receive the message on the topic of interest. In the subscriber, we'll enter the same topic name as a publisher and set QS after hitting the subscriber button, and data will be received on a subscriber. So here we can see MQTT works with so many platforms, and there are so many libraries for MQTT like Node.js, Android, PHP, and .NET. So first, the Node.js, the MQTT library provides the Node.js client MQTT. It allows you to connect to the MQTT broker and subscriber topic. Then there is a .NET library. There are several MQTT .NET library available like M2 MQTT and MQTT net. So also go for the Android, like in the Eclipse PAHO MQTT Android service provide an MQTT client for Android. It allows you to connect to an MQTT broker and subscriber. To survey the service will run in the background also even if the app is closed. Also same goes for PHP. By using MQTT box with the MQTT client library, you can quickly test and debug MQTT communication without having a you don't have to write a custom code. So that's all about MQTT. Thank you.